Alright guys, so if you watch the video of the guy going down that water slide, you probably noticed that as he went around the bends of the slide, that's where he was traveling really, really fast. Every time he went around one of the bends of the slide, his body shot to the outside edge of the slide, and the actual slide, the wall of the slide was built up on that side, so he wouldn't like shoot off and go flying off the slide. The exact same thing happens with our meandering stream. So if I draw a picture of a meandering stream for you here, you could see that it's meandering because it has all the like the curves and bends as it's traveling down. The same thing that happens to that guy's body as he travels through the water slide happens to water in a meandering stream. Water comes in the meandering stream and it always hits the outside edge of the meanders or the curves the fastest. So the water is always traveling the fastest when it hits the outside edge of the curve. It then bounces off that edge and travels to the outside edge of the next curve, and then it bounces off that one and it travels to the outside edge of that curve. And wherever the water is hitting the edge of the stream bank the hardest or the fastest, that's where the most erosion is going to take place. So there's a lot of erosion taking place on this curve, on this edge of the curve, and on this edge of the curve, because the water is hitting those outer edges of the curve really, really hard and really, really fast, and it's kind of breaking down and eroding the stream channel right there. The water is traveling the slowest on the opposite side. So over here on the inside of the curve, the water is moving a lot slower. It doesn't have as much power on the inside of the curve. So the water comes in and it hits this side, and then it hits this side, and then it goes down and it hits off that side. Whenever you have a straight curve, a straight stream, one that's not meandering like this, if I have a stream that's kind of just straight like that, the water just always stays moving fastest right in the middle of that stream. So if this is an aerial view of the stream, so I'm like above the stream looking down on it, but if I wanted to like cut this stream in half right here and draw what the stream looked like from the side, it would look something like this. I'm going to call this side A and this side B. So I'm going to draw a picture of what it might look like. Here's side A, and here's side B. The stream channel would create like a V shape to it like that, because the water is traveling the fastest right in the middle of the stream, and that's where the most erosion is taking place. That's where the water is carrying the most particles with it, and therefore it is weathering down or eroding down the stream channel the most right here, right in the center. So the stream channel has like a V shape to it like this. But what you guys need to be able to do is identify what the cross-section of a stream looks like in a meandering stream. So I'm going to draw my meandering stream again, actually. Let me draw it to the side so I have some more room. Okay, so here's my meandering stream. Let's draw a cross-section from here to here. We'll call this one A and B. And then I'll draw a cross-section here, and this one will be C to D. So the water comes in and it's traveling the fastest on the outside edge of the curve. So over here on side A, that's where the water is going to be traveling the fastest, and that's where the most erosion is going to be taking place. So if I were to draw a side view of this, here's A, here's like the top of my water, I guess, and here is side B. What happens is, because there's so much erosion on side A, because the water's traveling faster, side A gets carved out and it gets really, really deep there, whereas side B is much more shallow. So rather than having that perfect V shape, it's a little bit skewed because it gets deepest over here at A, where the most erosion is taking place, and shallowest over at side B, where the least amount of erosion is taking place. It then bounces off that and hits into side B over here, or side D over here. So side D is where we are fastest in this scenario, and side C is a little bit slower. So if I were to draw this, it would be the opposite of AB. It would be deepest now on side D and more shallow coming from side C, because D is where the water is moving fastest and where the most erosion is taking place. So it gets really deep on side D and shallow on side C. If, I'm actually going to erase the bottom here, let's say then this stream all of a sudden, you know, straightens out and now it's going straight down here. If I were to draw a third cross section from E to F would be perfectly even where the deepest point is in the middle. So if you can see the difference, from A to B, the deepest point's on the left. From C to D, the deepest point's on the right. And E and F, the deepest point is in the middle. The middle only happens when you have a straight stretch. Whatever side is deeper always tells you where the water is moving the fastest. And that's always, always, always on the outside of a curve. So you're going to need to be able to draw these for the Regents. And I'm actually going to post about 7 practice Regents questions, multiple choice type questions, where they'll give you a curve and they'll ask you which of these stream profiles matches it the best. So that's what you're going to have to be able to practice. I want to tell you 2 more things. As a stream gets older, it gets more bendier. So a stream, might start off nice and straight, and over time, all of a sudden, it starts to bend just a little bit. And then once it starts bending, now I get a lot of erosion on that side and a lot of erosion on that side. And the bending is just going to eventually get even more exaggerated, like this. So the older the stream is, the more bendy it gets. And the one last thing I want to talk to you about are these things called tributaries. So if this is my main stream, there are other smaller streams that empty into the main stream. And there are other streams that empty into that stream, and there are other streams that empty into that stream, and there's a whole system of streams that kind of looks like this. I think it looks like veins or something. But what happens is if it rains over here, that rain enters into this little stream, and this stream flows into this stream, and then this stream will flow into the main stream, and eventually all that water in the main stream is trying to get released out into like a body of water, like a river or a large lake or something like that. These are called tributaries, like this. Tributary. That's what those are called, tributaries. Those are small streams that enter into a larger main stream. All right, guys, so I'm going to leave you there. There's one more video I want you guys to watch, and then after that, I want you to go ahead and try those 7 practice questions.